Hello, my name is Ethan Sporta, and today I'll be presenting to you my product, Thermalite. So, really quickly, before we dive into this presentation, I'd like to swiftly present to you the outlines of the presentation. So, first, I'll be presenting the problem, which is the reason for my machine. Second, I'll be presenting my solution to the problem, which is the machine that I'll actually be creating, or my deliverable, essentially. Third, I'll be showing you the main components of the solution. Fourth, I'll be showing you the state diagram, which is just a diagram that explains how all the components work together to make the machine work. And fifth, I'll be displaying the bill of materials, which is the items used in the machine and the cost for each item. And finally, sixth and finally, I'll be showing you why my solution is the best solution. So, first, the problem. The first thing is that Americans waste a significant amount of money every year on their power bills. So, this is a major problem that basically everyone faces, and that alone would be enough to merit a solution, but solutions to this kind of already exist. So the next reason, and more personally to me, is that my dad, whenever I forget to turn the lights off in the room, which is quite often, gets very mad. So that's really my main reason to be it, and the first reason is kind of the more secondary reason. I know it seems kind of backwards, but I don't want to get yelled at by my dad. So, in order to tackle this issue, I created a problem statement. Now, what a problem statement is basically is just a statement that you can continuously go back to whenever you need guidance or you forget what you're doing. The problem statement helps you have a target or a problem to solve. So, what my problem statement is that there is a need for an automated system that detects human presence in a room and turns the light off when the room is unoccupied to reduce waste of electricity. So, with this being said, my solution is the following. On the right-hand side, you can see my sketch, which is in my engineering notebook, and I detail all the main components with notes and possible solutions. So this was my original idea, and basically it's a system that automatically turns the lights off when I leave the room, because again, I often forget to turn the lights off when I leave the room. So the way it solves it is by having a heat camera that detects whether you're in the room or not. And if you're not in the room, then it activates a solenoid, which is basically just a way of physically turning on and off a light switch. So that is essentially what the machine is. But the main components that it'll be using are an MLX 9640 heat camera, a Raspberry Pi microcontroller, as well as a breadboard with wiring connected to the solenoid, which is which is the component that will turn the lights on and off physically. So this being said, my first component is the heat camera. So how the heat camera works is that it takes in a bunch of pixels and it generalizes the temperature of those pixels. And then it detects the pixel heat and generates a live heat map similar to what you can see on the right-hand side, with more yellow being hotter and more purple being colder. So what this will be used for is that this heat map will be used as our machine's input. The second main component is what we use the heat map for. So essentially, we take the data from the heat map and run it through code on a Raspberry Pi microcontroller. So on the right-hand side is the code that I wrote, and what the code would do is that basically it sets a temperature threshold of 30 degrees Celsius. So if there's anything above 30 degrees Celsius in the room, then it sends a zero, meaning that there's somebody there. And if there's anything below 30 degrees Celsius, it sends a one, meaning that there's nobody there, the solenoid can activate, and the lights will turn off. So the third main component is the wiring. So I created this on Tinkercad, and this is a diagram of how the wiring would look like. On the left-hand side, we have our Raspberry Pi microcontroller, and connected to it is a GPIO pin 18. So the microcontroller, what that does is that processes the code. So this is the microcontroller, and it'll process the code. And then from there, it sends a signal into a MOSFET, which is basically just a method of controlling large loads like is needed for the solenoid. Because the solenoid needs a lot of power, it needs to go through a MOSFET. And I have a pull down resistor because that's how a MOSFET works. And then finally, this LED over here, it actually represents the solenoid. Because I couldn't find a solenoid on Tinkercad, this is representing the solenoid. So it's basically just the output. So that's basically the extent of the wiring. It's not too complicated. It's actually quite simple. And yeah. So when we put all of these components together, they come together and form a whole process in which if you're if you're not in the room, the lights turn off, and if you're in the room, the lights stay are able to stay on. So this whole process is clearly demonstrated by a state diagram. So we start down here at the black dot, which is a start node. So it automatically starts when a solenoid is inactive, meaning that there's someone in the room and the light doesn't need to turn off. This sends a 0 signal to the code because the solenoid does not need to activate. So if every pixel temperature is below 30 degrees, meaning that no part of a human is in the room, that means that the solenoid activates or there's no one there. So that sends a 1 and the solenoid activates and the light turns off. And if any pixel temperature is above 30 degrees, any pixel temperature being because um, you not all pixels in the room would be above 30 degrees if there's a human presence in the room. So yeah, anyways, if any pixel temperature is above 30 degrees Celsius, then the solenoid returns to being inactive. And then these side ones are just feedback loops. That essentially means that if if the past state is true still, then you just keep doing it, keep doing that action. So, um, the bill of materials. So what the bill of materials is, as I explained before, it's basically just an assortment of all of the items that I'll be using. So on the left-hand side is the cost, the item, and the cost that I got off of Amazon. Now, it is worth noting that the total cost of $146 is a misrepresentation of what it would look like if it were to be actually mass-produced. For example, take the jumper wires, the second item on the list. Those come in an assorted pack of $6. But in reality, you only need maybe one or two jumper wires for this to be mass produced. So if it were to be mass produced, not only would you only get a certain amount of each component, but also because of just how things work, the more of something that you produce, the further the cost goes down. So essentially what I'm trying to say is that the cost would go down if this were to be mass produced. And this is really important because it is one of the two main reasons why the solution is better than existing ones. So the first reason is simply functionality. Um, Existing automated lights are activated and deactivated using motion. So I don't know if you've seen, but in restaurants, sometimes they have these motion activated lights whenever you go into restrooms. So this is a problem for me personally because whenever I walk into a restroom and I'm stationary for too long, the lights don't detect me and the lights go out. And that's very annoying. I really dislike it. So I decided to make my component based off of heat, which avoids this issue entirely. That way I won't have to be flailing around while I'm on the toilet trying to get the light's attention, so I won't be in the dark. So it's basically just better functionally. It's a superior product. And the second reason why the solution is better than existing ones is the cost. Now, as you saw before, the cost is quite pricey, but if this were to be mass produced, it would be around $15 to $30. And this price was achieved I got this price by feeding the bill of materials as well as a detailed explanation of the project idea into several AI chatbots such as ChatGPT, Gemini, Claude AI, and several others. So, um, the reason that the reason that this is a good price is that it's similar to existing automated lights. And you may be thinking, well, oh, similar. Well, why wouldn't I just want to get the cheapest thing? Well, the reason is a combination of these two reasons makes the product superior. If you just have a better product for the same price, it's a better product. You're going to want to buy that thing. So, if you take away anything from this presentation, please take away this. A better product for the same price, Thermalite. It's that simple. It's just a better product for the same price. Thank you. And these are my references. So on the right-hand side are the references to the resource, the resources listed alphabetically in APA format, and on the left-hand sources are the links to where I got all the prices from on Amazon. And that is it for my presentation. Thank you.